Hello, everyone. Thanks for joining us. My name is Frank Conkle, and I'm the events editor and tech reporter for Government Executive Media Group. It's my pleasure today to welcome you to our Nextgov viewcast, Keeping Pace with Big Data. Events like these wouldn't be possible without the support of our underwriters, so I'd like to take a moment to recognize the exclusive underwriter of today's viewcast, SAP. A bit later, Government Executive Media Group President Constance Sayers-Witherspoon will sit down with Dante Rishi from SAP to continue this conversation. In a few minutes, I'll turn to you, our viewers, for your questions. Please submit them at any time by tweeting at us using the hashtag #KeepingPaceWithData. And now I'd like to introduce you to today's speakers. Directly on my left, we have Micheline Casey, Chief Data Officer, Board of Governors for the Federal Reserve, and Kalev Litaru, Yahoo Fellow in Residence for Georgetown University. Micheline, kick us off. Tell us a little bit about yourself.
Hi, Frank. It's nice to be here. Thank you. I'm Micheline Casey. I'm the Board of Governors Chief Data Officer and the Chief Data Officer for the Federal Reserve System. I have been at the board for almost a year and a half. My office was actually created about a year and a half ago following the financial crisis when the board realized it had more data than it was dealing with ever before. We collect data from a number of financial institutions here in the U.S. We also purchase data from a number of vendors, and certainly the volume and complexity of the types of data we've been dealing with has been skyrocketing these past few years since the financial crisis. So my office, the Office of the Chief Data Officer, was set up specifically to help the board with data governance, data management, and creating an improved analytical environment.
Kalev.
So I'm the Yahoo Fellow at Georgetown University, sitting in the Foreign Service School. And really what I focus on is how do we take the world's largest data sets, the world's largest computing platforms, and new ways of thinking about data, and use that, really combine that together to try and reimagine how we understand ourselves as a society. And specifically within the federal context, how do we really move decision-making beyond gut feeling towards concrete numbers that can at the very least, play devil's advocate to the decisions that we make, and hopefully eventually allow us to be much more responsive and react to the world in real time in a much more effective way.
I think, Micheline, when you kicked us off, you talked a little bit about how you guys got into big data. And I think if you take a little bit to explain what the Reserve does and why the crisis, the financial crisis a few years back, kind of spurred you guys to get into that field and collecting more information, that would probably educate our audience a little bit.
Great. So I'm happy to do that. And first of all, I do have to say that any of the views that I express here are my own and not those of the Federal Reserve Board or the Federal Reserve System. And so for those of you who don't know, the Federal Reserve Board and the Federal Reserve System is the central bank of the United States. Our duties fall into 4 general areas. We conduct the nation's monetary policy in pursuit of maximum employment, stable prices, and moderate long-term interest rates. We supervise and regulate a wide array of financial institutions, and more so since the financial crisis and the passage of the Dodd-Frank Act, but really to ensure the safety and soundness of banking and the financial system. Thirdly, we maintain the stability of the financial system and contain systemic risk through macroprudential regulation and policy making. And then finally, we provide financial services to depository institutions, the U.S. government, and foreign institutions, and we operate the nation's payment system. To perform these functions, the board uses a wide variety of data. Traditionally, it's been macroeconomic data. It's been survey data, such as the Survey of Consumer Finance, and then financial institution structure and aggregate data. But post-financial crisis, we've been dealing with a number of different types of data, and certainly, again, the volume and complexity of those data sets has increased significantly. As an example, we've got more business emphasis on macroprudential regulation, systemic risk and financial stability, and expanded supervisory functions. And we also have a need to understand not just the macroeconomic health of the country, but also what's happening at a micro level. So the new types of data that we're dealing with include third-party data that we purchase from vendors such as Bloomberg's, Thomson Reuters, Haver. We're collecting both macro aggregated data from financial institutions, but also microloan data now from financial institutions. And we're dealing with a lot more unstructured data, whether we're talking about actual documents, supervisory documents, that our bank examiners are collecting, or social media type data to look at what's happening with consumer sentiment and other types of data to help us understand trends going on in the economy.
Now, Kalev, you have some interesting views on where we're at in the government from your perspective in big data. I'd love to hear them. Give me a rundown here.
Yeah, I mean, the old question, what is government doing with big data? And the answer I always say is nothing. It's not quite that bad, but I think we have to draw a huge distinction between, just having lots of data and what we actually do with that data. You think about what we use the term, big data. The companies that come to mind are things like Google and Facebook and Twitter. The U.S. government doesn't oftentimes come to mind as right in the pinnacle of big data. Yet the government has enormous repositories of data, and I think a lot of that is this need to kind of move beyond, just saying, well, we have 500 petabytes of data. And really move towards, well, how are we going to use that for decision making? How do we both apply that, to actual questions that we have, but then how do we start exploring sort of what I call the sort of post-theory world, which is where with enough data and enough computing power, we can actually have the algorithms tell us, well, there's something interesting over here. There's something happening in the markets over here. Or there's something happening in Ukraine over here that you should take a closer look at. Mm-hmm. And that's where I think the real future comes is when we allow the machines to start at least playing devil's advocate and pointing us to things.
So it's not just the size, the amount of data that you have, but more importantly, moving forward, what you're doing with it. And that's a great segue to talk a little bit about analytics from your perspective at the Reserve. You talked about taking new types of data in. You're also taking larger amounts in at a more rapid pace. I believe some of the stuff you take in was quarterly, over long periods of time, more historical type information. Now you're able to take, like you said, information from things like Twitter even. I mean, information that probably you wouldn't have considered a few years ago as integral to what you do. And then you're taking that, using it to inform your decision makers, the board, mm-hmm. to create policy or to govern. I think that's something I really want to hit a little bit on here. Where do you guys see analytics now in the Reserve, and then how do we maximize those capabilities moving forward?
Yeah, so and I will say big data for us is probably not big data for lots of organizations. I think Kalev has a really, really good point. But certainly we are dealing with more data than in the board's history, and so for us it is big data. And it's becoming increasingly very complex and very unstructured. And so beyond just the analytical purposes, we also have to look at our ingestion mechanisms, the way we aggregate, match and merge data management, data governance, as well as the back-end infrastructure. But in terms of some of the things that we're starting to do, so one of the things we don't want to do is just do big data and experiment with big data for the sake of doing big data.
Right, because that can get expensive if you don't know what you're shooting for, right?
Absolutely. And we have a fairly conservative culture at the board. We are the nation's central bank.
Big shocker.
But our business needs are changing, and we have a couple good examples. We have a division of consumer and community affairs, and they really focus on the impact of financial institution policies on citizens. And so what they've been starting to do the past couple years is leverage social media to pull in massive streams of data to understand what's happening with auto loans, with foreclosures, with consumer credit cards, and pointing them in new directions, whether it's emerging policy issues or trying to get out in front of what, from a research perspective, they should be looking at in terms of running their business.
It's a much more granular approach, isn't it?
Much more granular approach than it used to be. On the macroeconomic and forecasting side, certainly we're seeing a push towards a trend called nowcasting, which is historically we'd be looking at 3-month-old, 6-month-old data to try to predict where GDP is going or where unemployment is going or what the overall macroeconomic health of the country is. And now we're starting to do things like look at Google Trends data, looking at newer types of data, new emerging sensor data, et cetera, coming out to understand what's the real-time health of the economy today. I like to use the term Fitband for the economy, but you can imagine, Fitbands are used to monitor ourselves. What can we be doing with data to let our Federal Open Market Committee and the chair and the policy makers at the board understand what's really going on in the economy today, leveraging emerging data sets.
So you're seeing your patterns and things like that can actually translate directly to policy in a pretty short order.
It could, right? So certainly we require lots of precision in the statistical work that we do, in the policy setting that we do, but being able to leverage these new data as indicators of other things that can be going on, or act as devil advocates, or start to influence the way our policymakers or our researchers are actually thinking about what's happening now is becoming increasingly important.
I want to hit on strategy for how you go about doing that soon, but I also want to ask Khalif, you kind of put together a pretty interesting project. I think that it's focused a lot on patterns, taking large data sets and then finding out pretty cool things that otherwise people would have no idea were going on with human society. So tell us a little bit about that, because I think it's interesting.
Yeah, so one of my projects, the GDL Project, GDELT-project.org, it's really it's an academic project to essentially scoop up the world's news media, process that by computer, and essentially create a running catalog of what's happening around the world: riots, protests, coups, peace appeals, diplomatic processes, but then also the context. How is this being contextualized? Is this an anti-government protest? Is this an economic, a food protest? And then how are people reacting to it? Are people saying, wow, this is great that people are bringing this up, or are they really down on it? And once you have this amount of data, right now it's about 250 million records going back to 1979 covering the entire world, you can start doing very interesting patterns with that. So, from a policymaking perspective, I actually made a map on the day before the president of Ukraine fled. And this map actually showed that the protest really has spread across all of Ukraine, and Crimea was lighting up red hot. And I actually got unilaterally negative reaction to that map from policymakers saying, well, this can't possibly be, Crimea, this is just the capital, they just signed a peace deal with the protesters. So, Ukraine's going to be at peace very shortly from now. And so again, playing that devil's advocate piece, but and that was a very targeted map, where it was, here's an interesting situation that's happening, let's learn more about it. Just this past week, in collaboration with Google, one of the things that we tested was actually taking this all 250 million records and saying, what would happen when we start teasing out patterns at scale from this much data? So we actually took, as a test case, the 2 months of Ukraine, right before the president fled, and actually had basically Google's BigQuery system basically scan across all world history, at least the last 35 years of it, and look for every 2-month period in all world history that looks most similar to where we're at right now in Ukraine, or where we were at that point. And then after each of those periods from world history, what happened after each of those? And look to basically the past to say, well, in the past when we've had situations similar to now, what happened afterwards? And it turns out that actually gives you an incredibly accurate forecast. It's not perfect, but it actually matches these complex up and down cycles. So to me, this is really, I think, where the world would be heading, where we're able to with data sets of this magnitude, let the machine sift out these very interesting patterns, the actual underlying patterns that no human could look across 1 billion records and actually run 2.5 million correlations, literally comparing every single portion of time in just 2.5 minutes. And that, to me, is really where the future lies.
Now, this might sound like a devil's advocate question. We bring up devil's advocate quite a bit in this conversation already, so I hate to do it. But I always wonder, with the advancement of algorithms and technology and even robots now close to entering our workforce, what if they're wrong? What if an algorithm tells you things that's, inherently it turns out to be wrong? How do you deal with that? I mean, you're in an agency where if something isn't correct, an assumption that you make is wrong. You said you have to be very careful, but what happens then?
We have global systemic implications if we're not right? So we do take things very cautiously and very carefully, and I think certainly in our world, the computers and the artificial intelligence would never overtake the human reasoning beyond the policy making and the research that actually happens.
So the answer I'd like to give to that, though, is, we talk about, well, when are computers wrong? Well, humans don't have the best of track records either.
Good point.
And so really where I come from it is, at least with a machine, you can say, well, why did it make that decision? Why did it do that? And increasingly, I think it at least also helps. You think about the advent of satellite imagery. It allows us to move from, you think about oftentimes it's a policymaker facing a 20-year-old who, and they say, well, you're a 20-year-old straight out of college in a fabric-covered box, across the Potomac. How would you know what's going to happen in Ukraine next? So at least data helps us with that. But I think to me the greatest thing that we need today is if you look at the intelligence assessment, when you're dealing with a human source, you have all the caveats down the side that say, well, this person has ties to this and this and this. So we have all these caveats that really contextualize it. When we use computer algorithms, we don't have any of that. All you have is, the meaning of life is 42, and that's it. No reasoning behind how you got there. And I think as we get more, as data reaches maturity, I think we're going to have more of, it's going to have all the characteristics that we need. What's our confidence? What's our sort of, how likely do we think this is going to happen?
Probability kind of thing.
Yes, those are things that are missing.
So before we go any further, I want to remind our viewers that you can tweet questions using the hashtag keeping pace with data. Keep them coming. These guys will be able to answer about anything. We have a few right now I want to get to. So this sort of pressing into what we were talking about. What kind of budget does it take to pilot some of these programs? I guess, how did you get started with this? How did you go about getting buy-in to get going on some of this, Micheline?
So my office actually got created pretty much through consensus, a couple of years ago, a year and a half ago now. But in terms of how we're starting to move forward slowly with big data and analytics, we've traditionally had a pretty large budget across the board for data purchases themselves, and certainly for acquiring data from financial institutions. What we haven't had heretofore in the past has been an influx in infrastructure and related investments. And so as we work through our enterprise data strategy this year in partnership with our division partners and our IT partners, we will actually be trying to figure out what that infrastructure budget looks like to support the work that we're doing. Right now we have a Hadoop cluster, we have Linux servers, we've got a massive Hadoop cluster down at the Kansas City Fed that's doing a lot of really cool things down there. But we are pacing this forward pretty slowly. We're under the same sort of budgetary constraints that the other federal agencies have. And so the work that we do really has to align with what the business drivers are and the changing business needs of the organization are, and to identify those specific use cases where we're going to focus in on and then start to build the presence out from there.
So it's not a rapid fire type process.
Definitely not. Definitely not.
And where are you guys?
A measured approach.
Where are you guys in your enterprise data strategy? Is that still in the very early stages, Greg?
We are in the early stages of it. We've spent the last year and a half out meeting with our stakeholders, not just at the board, but across the Federal Reserve System, and also with industry partners. Certainly, we put a lot of burden on financial institutions in the financial sector by acquiring massive amounts of data from them, and so we are taking their needs into consideration as well. We also consume a lot of data from other federal agencies, so efforts like the open data efforts are really important to us as part of our overall enterprise data strategy, and improves our ability to ingest quickly the types of data we need from Census, from BLS, from EIA, from a number of the other agencies. So we're working on that now, and we've got lots of parts and pieces of it sifted out, and now it's a matter of working it through a framework and getting support across the board. We're also building out our data governance framework to be able to handle not just current data sets, but new data sets, and the rapidity at which we need to be acquiring data sets and merge them in with existing data sets. And we're also building out our information architecture and broader data management frameworks to account for all of these new types of data that are coming into the board.
Caleb, do you have an answer for that? What kind of budget it takes to get some of these, or some examples that in your work on the academic and private sector side where you can relate a little bit?
I mean, my work is kind of unique in that my work is entirely unfunded. All of the projects that I do are basically gift in kind, volunteers. So I think in a way my work kind of it stands testament to where we're at in the big data world. In that we've reached a point now where the entry point, you don't need to spend $100 million, buying this massive computing infrastructure. With the cloud, you can essentially rent what you need. You can essentially, and as you grow bigger, if you need all of a sudden the ability to process 100 petabytes for a few days, you can do that, and then cloud, and then burst back down. So I sort of sit in a strange realm in that I've had to bootstrap most of the things that I do, but I think that says something in that it's easy today to experiment. And I think one of the greatest failure points that we've had in the federal space is that the federal government tends to think sort of it aims big and it won't stop until it gets there, versus Silicon Valley is much more the fail fast, fail early, fail often mentality. And I think that's one of the interesting realms today is you can do that. I wonder, and you can actually in an afternoon, one single person spending a few hours can test that and say, wow, there's something here. This is worth investing in. And I think that's really interesting. Again, that's very different than kind of the operationally focused work the Fed's doing. My work is much more on the how do we sort of keep advancing, find interesting new application areas.
There's a risk to each approach, right? I mean, you can spend a little bit of money, and if it doesn't work, you can keep trying different ways to find something that does work. You guys, on the other hand, if you mess up or something screws up, there's a lot of people, there's a whole government that relies on what you do.
Well, a government, but really if you look at the globally interconnected financial system, we're really talking about global implications potentially with the work that we do. But I think another area for folks another way to frame it is for folks to really take a step back and look at the data they already have in-house, because every federal agency has a massive amount of data in-house. So this isn't just about collecting the new stuff that's out there, but it's in part understanding what you have and how to match that, merge it, create insights, and integrate that data in ways that potentially you've never done before because everything's been completely siloed off. And so that's actually a really big step forward to a number of agencies. And then having the ability to then mesh big data sets coming in, whether it's social media data, news data, unstructured document data, to take it to the next level is also another way, I think, for agencies to approach this type of activity.
Now, that gets me to something. So Cobb's kind of a one-man show in what he does. I'm curious about, and I don't want to get too in the weeds here on you, but how big is the team that you have to work with on this? Because given the magnitude of what you're doing, you would think it'd be sizable, but I'm curious.
Well, so there's the Office of the Chief Data Officer, but the reality is the work that we do impacts the entire Federal Reserve System, and certainly in many ways, and certainly the Board of Governors. So within the Office of the Chief Data Officer, I think we're at about 35 people, scaling to about just under 50, maybe 45 by the end of the year. But we work very deliberately with our stakeholders across the board's divisions because we're not the subject matter experts in the work that they're doing. The data stewards reside in those divisions. The researchers, the economists who are playing with these data sets and really understand these data sets are in those divisions. So it's definitely not OCDO doing everything. It's a true partnership with those at the board and the national lines of business that we serve across the Federal Reserve System.
With the rise of importance in analytics and data you have, data you can get from elsewhere, do you foresee a change in sort of the workforce that you would hire? Are we talking like data scientists and analysts that would be more integral now than ever before for you guys, or no, not yet?
I think we're actually getting close to getting a couple of our first data scientists in, hopefully. But I think certainly, and it's not even dealing with the new data, looking at how we have to re-architect the back end to deal with this, and trying to automate more of what we're doing, leveraging new technologies, means that we do need to bring in new types of data, and not just on the analytical side, but also on the infrastructure side as well. So one of the things that's really going to be important for us in 2015 is starting to build a pipeline of new talent, whether it's through intern programs with academic institutions who are really building programs out. There's some really good talent at a number of institutions across this country who are starting to build data science program or big data programs, and we want to be attracting them in. We have some really amazing data sets. We have some really impactful data sets, and it's going to be increasingly important as our workforce matures and as technology continues to hyper-pace forward, and as new data sets continue to hyper-pace forward, that we've got talent in-house and feeding that pipeline keep us fresh, keep our thinking fresh, and make sure that we remain not on the bleeding edge, because we're not a bleeding edge institution, but certainly out in the forefront of the work that we could be doing.
So I suspect on the bleeding edge there are some risks involved. There's an audience question that deals with that. It says, what are the risks with big data? Privacy is an issue, but what are other considerations you have to make with these new emerging technologies? I suspect some of the work you've done when you're talking about Crimea, for instance, when you're pulling in large amounts of information, there are privacy concerns. But what are the risks? Are there risks?
Yeah, I mean, there's a lot of them. I think the greatest risk we have today is there's still this sort of huge chasm, this massive divide between the data sciences folks and the domain experts. And at least in the fields that I am, in the policy fields, the two sides really don't trust each other, and we're not getting enough sort of conversation. So oftentimes you have, like in most companies, most Fortune companies I've worked with have faced this now, where as business analytics spread across the enterprise, you have someone, for example, that takes some data set, the classic, single version of the truth. Is it a sale, when we ship the product, or is it a sale when someone has committed to potentially buy something? And so as, you're, in the old days, you had sort of your central data scientists, who knew all, they had all these, they knew each data set and what its nuances are. I think as more people are experimenting with data, we have more dangers in that people are using data sets in ways they were not intended to. Famous, simple example, I was at a talk where this group was presenting how the Syrian rebels felt about their government, and it was beautiful visualizations. I call it the Apple effect, because things are so, the visualizations are so amazing, you don't ask the questions. And I raised my hand and said, what is this data set? And they said, well, English language geotagged tweets. There's so many things wrong with that sentence. And I think that's part of it. I think the other part is that still the algorithms are a black box. That you say, well, make me a forecasting algorithm that does this, and a data scientist goes back, and they come back, and you say, well, how is this working? And they give you a 50-page mathematical equation, but there's nothing in there about, well, how reliable is this? What is my confidence in this?
Yeah.
And the example I always give is you look at like maps today, and you just see points in a map. There's nothing in there that says, well, how certain am I that this is at this location? And military cartographers talk about spatial confidence, and they actually have error bars that say we think it's here, but it could be anywhere in this area. Those are all the things that are missing today from how big data is being used. So I think that's kind of the next step, is that most of the dangers today is that data sets are being used outside of context. They're being repurposed in ways they were never designed for. And if you understand what you're doing and you bring the nuance to that, you can still do that. But I think oftentimes it's sort of, hey, cool data set, here's a piece of software, shove the two together, I get results. It's the sort of the shiny new object syndrome.
Right. How about you at the Reserve, Micheline? Are there conversations that take place behind closed doors about this could be risky, this data set could include something risky, it could be PII, there could be that kind of thing in there. How do you handle that, I guess?
So we probably have 3 or 4 different categories of major risk that we look at. Certainly, with the traditional work that we've done, we actually don't have a lot of data that has PII in it, right? We're dealing with financial data, we're dealing with economic data, we're dealing with statistical data, and so generally speaking, the PII equation is taken out, but it's substituted for something that we call confidential supervisory information, and that is essentially when the financial institutions give us their balance sheets, give us their loan information, that's their version of PII, right? It's their books.
Maybe that's not something they want everyone knowing.
It's not something they want everyone knowing. Certainly their supervisors need to. Certainly the supervision line of business needs to. But we also have Chinese firewalls oftentimes between the monetary policy people who would love to get their hands on specific micro data sets and the supervisory side, and vice versa, because there are very specific reasons why we keep the data confidential and supervisory in nature. And so we do have that Chinese firewall that we make sure that doesn't get breached for the financial institutions' benefits. I think some risk comes into something that Caleb said earlier, and that is having blinders on and not having a strong cross-disciplinary approach to understanding and looking at the data, having folks sitting there in isolation and making decisions around that, which tends to really not happen, but certainly we want to ensure that doesn't happen. I think another area for us is certainly as emerging data sets come out, because of the precision of the work that we need to do from a statistical perspective, these emerging data sets aren't proven statistically. The survey methods for collecting these data isn't consistent and isn't consistent over time, persistent over time. And so there are dimensions to these newly emerging data that we also have to take into consideration and know where the boundary is between the precision around them and can they actually be used to set an interest rate, or are they just indicators of things that are great for some policy influence or economic research purposes, but aren't the type of precision that you would need to determine whether or not you're going to move the interest rate up and down, right? So there's those sort of factors that we also are looking at within the Fed.
I mean, it seems like when we hear it straight from the Fed, as it is, we kind of see why it's not easy to get into big data right now, why we're maybe just, as baby steps. There are so many different factors that go into how do we examine this information? Why do we need analytics here? What can it produce? It's a lot to get your head around. So when you're putting the strategy together, this question here came in. We sort of touched on this a little bit before, but how do we educate others in our organization and get buy-in when we're pursuing new capabilities? So how do we present the business case for this? How do we do that? I have no idea where I'd start.
So actually do it back in their language. So again, we've spent a lot of time over the last year and a half getting out in front of our stakeholders, the division directors, the section chiefs, the economists, the bank supervisors, the folks across the system, to really understand how their business needs are changing, what's changing within their world, and where their pain points are, whether it's around accessing data, even knowing what data we have, being able to integrate it easily, layering analytics on top of that for more real-time decisioning. All of those things are inputs into a strategy that then sort of needs to be mirrored back in their own language. I will say my biggest learning curve, quite frankly, in joining the Fed has been that I'm not an economist by training, and there's a lot of terminology, macroprudential regulation, that, for example,
we'll be talking about that at parties.
Exactly. Sure. That's a buzzkill at parties, and I'm not sure I still understand entirely what that really means, but it's really meaningful for a lot of people inside the Fed. And so understanding what data they need to use, both current and future state, in order to do that work, the analytical drivers behind that work are critically important. So understanding, again, just the language, the terminology, so I can mirror back in a strategy document. They don't care about information architecture, but they care about merging and integrating data sets and one-stop shopping for data that gets them what they need in the most expedient time possible.
I feel like there'd have to be a lot of strategic communication between your CIO folks, your CDO folks where you're at, and procurement too must factor in there somewhere. As these technologies get more mature and you need to go out and buy them, I mean, a lot of people are critical of government's procurement policies on tech, especially because it is changing so quickly. I mean, every few months there's a new version of a phone that would be great, right? The next generation. We can't buy them fast enough. So how is that part of your strategy yet on how, when we have a use that we want, how do we procure that? How do we get it in? And how do we do it in a fashion where in a year or two we're not still trying to get it and we're not behind? Because you guys have to make decisions quickly. It's part of your goal as your strategy. How do you get it on time, and how do you have those discussions?
So we follow the same procurement laws that the other federal, even though we're an independent agency, we follow the same procurement guidelines that all the other federal agencies have. We're fortunate in that the Federal Reserve banks themselves actually are private sector entities and not subject to FedRAMP and some of the other procurement
requirements.
We'll nicely call them requirements. So sometimes we will actually, in partnership with the Reserve banks in New York and Kansas City, are perfect examples where the New York Fed has the markets group, and they get stock market tick data. So nanosecond by nanosecond, every stock trade goes through the markets group up in New York for analysis to understand if there's anything at all going on with the stock market that needs to be taken into consideration. And the Kansas City Fed has our massive Hadoop cluster. So we're able sometimes to take advantage of the interesting way the Federal Reserve System itself was structured in order to move a little bit faster. But certainly at the board, we've got to follow the same guidelines as everybody else. So we've constantly have to be thinking, a year ahead and looking at infrastructure needs.
So as we're getting close to wrapping up, I want to ask you guys about the future of big data and analytics. I mean, those words have been tossed around only for the last few years here, heavily in the Beltway community. Where do you see this tying together? I look at it from a reporting standpoint sometimes as these are very intricately woven things, ideas, big data, mobile, to be able to get information wherever you are on any kind of device, and cloud, operating so that you can, spin up service as you need it, compute, whether it is analytics of the service. They're all seem to come together. Where do you guys see it from your individual perspective? Micheline, you as a Fed, but I want to start with Kalev here, because you have a very wide perspective and you kind of have a large girth of knowledge, if you will, on the subject.
The short answer would be read my next book.
Nice.
But I think the longer answer is I think as the field matures, as it moves from shiny new object, which is, I sort of liken big data to, Web 2.0. For the longest time, everything was Web 2.0. Well, what is Web 2.0? I don't know. It's Web 2.0. I think we've kind of have that now where, working with a lot of the Fortune 50s, you'll have, everyone's tossing on, we've got 50 petabytes. We have 100 petabytes. And you say, well, what is all that data? Go into the question of, what is all the data you have? And they'll say, well, that's the total sum of all the tape backups we have for every desktop in our company. It's like, well, how are you using that? How is all these? And we say, well, it's just, the amount of data. So I think there's still this notion of big data being something that we just need to acquire data and magically things will happen. I think the real maturity will be as we start thinking about what do we do with all this data our companies have collected, organizations, government, et cetera? What would happen if you took all the, just looking at the public data sets the government has, you think about, movements like data.gov. Data.gov took those first steps. You put all of this data up, but it's still just there. It's available now. It's all in one place. What happens when you start taking all of that and you start building these massive analytic models? I think the future really is going to be when we start thinking less about how do we collect this and manage this data, and really about what can it tell us about society, and especially the unexpected. What happens when you take these big computers and you handle all this data and you say, what's interesting in here? I think that's going to be the future.
So let's take that term actually off the plate. So a decade ago, I worked for a major data broker, and we were doing big data before there was a term, big data, right?
It was just data.
And certainly what we consider big data today is not going to be big data in 5 to 10 years, particularly as sensors continue to roll out and deploy. This is about organizations, whether you're a federal agency or not, proactively managing data in a way that makes sense to run and operate your business. And dealing with more and more means that you've got to change operationally the way you govern data, the way you architect for data, the way you manage data. We can't have these drawn out cycles because of the rapidity of change. We need to get into agile development a lot more. We need to take the user experience into account a lot more than we do in the federal government. And the federal laws need to start really emerging and changing to enable the federal agencies to do what they need to do in a more rapid period of time. But this is really about running your organizations as a 21st century organization, not as a 20th century organization where things don't change that quickly. We are in a hyper-connected world, hyper-paced world, and federal agencies just need to start thinking about it from that perspective. But the reality is the data requirements of the organizations will continue to morph, and what's big data today is not going to be big data tomorrow.
Right. It used to be that government drove technology in a lot of ways, and now it seems that technology is sort of beginning to drive government. Government will inherently have to change as these technologies come to fruition, because otherwise we'll fall behind everybody else in adapting new methodologies. And what this all comes down to, our conversation, is really better decision making. I mean, think about the data that you already had, you just didn't know how to use it at the Federal Reserve,
or
right?
we couldn't connect the dots.
And we're still connecting the dots better
Yeah.
than we were, and so we're doing that, and also, planning for the future. I think that's where when we go forward, we'll have to, have both the procurement part of this figured out, the strategy for this figured out, and big data will drive better decision making along with analytics as we move forward. That wraps this up. Stay tuned for Dante Ricci from SAP and Government Executive Media President Constance Sayers Witherspoon. They'll have a discussion that you'll want to see. Thanks, guys.
Thanks to Frank and our panel for that interesting discussion, and thanks to you, our viewers, for joining us today. I'm Constance Sayers Witherspoon. I am the president of Government Executive Media Group, and I am here with Dante Ricci, who is with SAP Global Public Services and Healthcare. We're going to continue this conversation on innovative adoption of technology within federal agencies. But first, a few words about Dante. He has more than 18 years of experience in technology, holding roles in operations, finance, solution engineering, solution management, strategy, and innovation. Dante recently served as the Senior Director, Solutions Marketing for the Global Public Sector team, where he played a significant role in achieving SAP's global mission, which is to help the world run better and to improve people's lives everywhere. Thanks to SAP for sponsoring today's Viewcast, and thanks to Dante for being here with me today.
Thank you. Thanks for having me.
So let's just get right to our first question. What are best practices that you would recommend to government agencies as they adopt big data management and analytics?
The best practices are pretty well known from a high level, but just talking with clients, working with clients over the last couple of years, when I think about big data, there's about 4 different things that I really would want to really just think about as a particular initiative has started. One is educate yourself. When you're thinking about utilizing technology, understand what technology you have today, understand what technology is out there. Think about something new, something groundbreaking, and try to be a little bit innovative when you're educating yourself so you can open yourself up and understand new ways of doing things. That is number one. Second, understand with your organization, your line of business managers, your directors, people that are inside the IT organization and outside the IT organization about specific use cases where you think big data might be valuable. Maybe ranking that particular initiative with not only the value of that particular case study or use case, but also the feasibility of getting that use case done. Then once you figure out, okay, we've educated ourselves, we understand that we have a good set of use cases and we want to pick this particular use case and go for it, start small. You have to understand and live it. If you don't live it first, you don't understand what's going on with it. We have a particular customer in mind that I think about with the state of Indiana. They want to reduce childhood mortality and fatality. And what they want to do is pull in multiple sets of information from different sources of data or different databases, whether it's structured or unstructured information. But what they did is they started with a key set of 12 particular data sets, got a feel for that, did baseline analysis and visualization with that, and then started reaching out and grabbing more data sets as they went along. Then they could understand that value. The other piece is you need to understand that you have to not only develop an architecture that's simple, but make sure that particular architecture is flexible, because you're only going to start with that initial use case, and you're going to build up that particular return on investment and value, being able to observe and orient with that data so you can decide and act better. But now you're going to try to increase that initiative more enterprise-wide or between agencies. And when you do that, you need to have a flexible architecture to do that. You have to be able to scale up and do different things. So think about that before you go in and think about technology from that one particular use case.
We just had a question earlier, I think Frank had from someone about how to start. So those were great ideas, like how you start, great practical advice there. What are some challenges that you have heard from agencies about achieving insight from big data?
There's several. We heard it with Micheline and a couple other folks earlier. I think Frank mentioned it as well, and also somebody in the question and answer session. And when I think about different types of access, one is security, being able to either anonymize the data or make sure that you have policy around that data so that you can slice and dice the data, but without hurting without going against any legal, statutory, or compliance situations, and also making sure you keep people's privacy where it should be. The second thing is access to that data. Lots of times you want to have, in the federal government or defense organizations, segregation of data on purpose. So if you want to understand about readiness for military readiness, you may not want to combine certain data sets. So you have to understand what access you can have, get memorandums of understanding between different agencies or different services when it comes to the military. But then you also have to look outside of your organization and understand that you can also pull in open data or data from social media, data from other aspects, to bring that together, video, etc., and to get a compiled view and complete view across that holistic enterprise. And that's a problem, again, when you have a stiff IT architecture. When we talked about the ability to have an agile architecture, you might be able to shut down certain sources and bring other sources on in real time or historical data, but you want to bring that in without having to do a large IT effort, if you will.
And my last question, are there some innovative ways that your customers are using big data?
Yeah, we can talk about this all day long. I wish I was here for the hour that we had. There's tons of great use cases. One, when I think about the federal government, I'm thinking about something very interesting that we're doing with Penn State University Applied Research Lab. They're doing some different things around vehicle health and taking sensors in real time, literally millions of data points from sensors, and pulling in to understand the virtual health of particular weapon systems or equipment or assets. You could use that with historical data to understand a true virtual health, not the actual warranty of the particular vehicle or weapon system, or when you think you should be doing preventive maintenance, but what actually is occurring in that piece of equipment. I think that's really, really interesting from a federal government perspective. When I reach out into the healthcare world, really, really interesting things going on, and this really pertains to all our citizens, our veterans, and anybody that's affected by different healthcare situations or health situations. But one particular organization called MKI is using Hadoop environment for historical data and SAP HANA in-memory platform, real-time in-memory platform, to take the historical data and the emerging data that's coming out real-time to understand the particular patient's risks. So if they come out with if they're going into the hospital with a particular cancer cell pathology, a stage, and some of the, what I would call some of the other parameters that you would look at when you're thinking about prescribing a certain chemotherapy or radiation treatment to a patient. In the past, if they wanted to do some genome analysis and get a profile of that particular patient so you can bring that in before you prescribe what that particular patient needs, that would take weeks or months and lots of dollars or money. Today, this particular organization can actually get that genome analysis done before you leave the hospital that day. Wow. With your diagnosis, combine that information with historical data so you have a good prescriptive use case, and also a way to understand what particular diagnosis there is and how you could fix that particular situation with that particular patient to make them healthy, or what gives them the greatest benefit.
Nice. Wow. Dante, thank you so much for your insights, and thanks to our viewers for tuning in today. If you would like to view the event again or share the archive with your colleagues, it will remain online for the next 3 months on our website. Thank you again for joining us, and we'll see you next time.
Thank you.